Okay, so today we're going to look at 3.1 squares and square roots. So our content objective for today is I can determine the square of a whole number and I can determine the square root of a perfect square. We also have our language objective, which is I can define the following concepts: perfect square, square root, and prime number. So by the end of this lesson, you want to be able to say I can to all three of those objectives. Now let's start with our first definition. So what is a perfect square? Well, it's a product of the same two numbers, which means that it's a number that's multiplied by itself. So when we look here, 3 times itself, 3 is 9. So that is a perfect square. 4 times the same of itself, 4 is 16. 5 times 5, etc. Now we're going to look at a question that we get asked a lot as math teachers. It's, why call this a square? Where did that even come from? Why talk about a shape when we're looking at something that's not related to shapes? Well, it's quite simple actually. When you look at it, this square that we're looking at right here, right, it has one side and another side down here. So we're going to look at the sides. Well, 1 times 1 is going to give us, we know from our math, 1. So the number of sides, one side times the other side, should give us how many squares there are. So 1. Now when I look at this again, let's say we try this again. Now when we look at this one, I've got two sides. 1, 2. So 2. And I've got another 2 along the bottom, as you can see sidewise. So 2 times 2 is going to give me 4. Well, that's how many squares I have in the middle now. And notice, what shape is it making this time? It was a square here, and again, when I arrange these squares, it's made an even bigger square. Well, let's try this one again. So, let's try the next number up. 1, 2, 3, and let's keep going here. There. So, when we look at the side here, we've got 3 sides. 1, 2, 3. So we've got 3. We've got 3 along the bottom here. So 3 multiplied by itself, 3, gives us 9. And take a look. The 9 are organized once again in, you've guessed it, a square. Just one more time, just for emphasis, let's go the next number up. 1, 2, 3, 4. And again this way, 1, 2, 3, 4. Sorry these aren't perfect, but you guys should get the idea here. There we go. So, when I look on the side again, this time I've got 4 on the side. The other side I've got 4. So 4 times 4 gives me 16. And 16 again is considered a square number because, dun, 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 you got it, this makes a square. So they're called squares because when these numbers multiplied by themselves, they actually can create the shape of a square. So just said before, when drawn out or modeled, the numbers form a square. So 16 is a square number because it makes a square. 9 is a square number because it makes a square. 2 is because it makes a square, and so on. If you did this with 36 times 36, you get a massive square. 100 times 100, an even bigger square. So anytime you have the number multiplied by itself, its answer should form a giant square. Now squares are also called perfect squares. When you have a number that's not a perfect square, it's called a non-perfect square. Now the first thing we're going to look at is these multiplication down here. Are these numbers squares? Well, when we look at 5 times 3, 8 times 2, 9 times 1, 4 times 3, 9 times 4, we have to ask ourselves, are any of these numbers multiplied by themselves? And the answer is no. So if I went to try to draw this, when I look at maybe 5 times 3, well, or right here, 1, 2, 3, 4, 5, 1, 2, 3, When I look at the shape that that answer makes, because we know 5 times 3 is 15, this doesn't make a square whatsoever. So we know right away it's not a square number based off of the fact that it doesn't make a square, but also because these aren't the same number. So the question we're going to ask ourselves is, how can we make them into a square? Well, quite simply with this one, I need to make sure it's the same number. So if I change that, if I change this to 5, and I add 1, 2, 3, so now there's 5 across the bottom, all of a sudden, I've got 25, and now I've got a square. So essentially, to make all of these work, we just got to change them to the same answer. So 8 times 2 is no longer 8 times 2, it's 8 times 8. 9 times 1 is no longer 9 times 1 because that would simply just look like this. We know that's not a square, so we change that to 9. 4 times 3 becomes 4 times 4. 9 times 4 becomes 9 times 9. And that's how we can get them all to be squares. Now, what is a prime number? Well, that's defined as a whole number that's greater than 1 that only has two factors, 1 in itself. So you can see here, 7, the only things that multiply to make 7 are 7 and 1. So that's a prime number, just like 11 would be, or 13, or 17, or 19, and so on, because those numbers have nothing that can multiply into them except for themselves and 1. Now we're going to look at what prime factors are. Well, that's just simply factors that are prime numbers themselves, that you can't go any farther down. So if we were to take 10 and divide 10 down, well, we know that it can be divided by 2 and 5, because 5 times 2 is 10. Well, 2 can't be broken down anymore because all 2 is 2 times 1. So that's as low as it can go. And 5 can't divide any lower because only 1 and 5 go into 5. So these numbers, because they can't go any lower, are now prime numbers, which are prime factors. Now let's look at some actual work examples here. So prime factorization, we kind of know this from last year, but we're going to do a bit of a review here again. We're just trying to break the numbers down into their prime number multiples. So we're going to take these numbers here and try to break them down until all we have is prime numbers. So we're going to start here by looking at 24. So we can break 24 down. Well, let's look at it. 2 times 12 gives us 24. So 2 can only be broken down to 2 and 1, so we've got one prime factor there. Now we can break 12 down further into 2 times 6. So we know that 2 is also a prime number, so we're done there. And 6 can be broken down into 2 times 3. So now we've got our prime number multiples. So that means that our prime number multiples are going to be 2 times 2 times 2 times 3 is going to give us 24. Now let's take a look at 36. Right away when we break it down, we know that 6 times 6 gives us 36. But we're not done there. Even though we know that they times itself to give you 36, we still have to break them down to the prime number multiples. And both can be broken down into 3 times 2 and 3 times 2. So now we've got our prime number multiples here. So multiples here are going to be 3 times 2 times 3 times 2 should give us 36. So that goes, they can't go any lower than that. And last we have 81, which we can do 9 times 9. Now again, we found a perfect square here, but we're not done because they can be broken down into 3 times 3 and 3 times 3. Now those can't go any lower, so we can circle them so we know that they're prime multiples. And we can write down that our factors then are 3 times 3 times 3 times 3 equal 81. Now, if we decide to go a different way here with 36 and break it down by 2 first, and we didn't have the obvious, 6 times 6, well, you can still figure it out because eventually your factors were going to be these. You were going to have 3 times 2 times 3 times 2 as your factors no matter what in the end. So all you have to do is if you had an equal number like we do here, we have 2 3s and 2 2s. That's a nice even number. If you put that down the middle and multiply them together, you should be able to know if you have a perfect square. Here we break these two up because we have 4 3s. Well, you put 2 on this side, and 3 times 3 is 9, and 9. If we go the other side over here to 24, if I split these up, now we've got 4 and we've got 6. And we know that that's not the same number times itself, so we know that these two obviously already are squares. But if you didn't have them broken down like this to begin with, then you'd have to use just your intuition to break up the factors, and if it's an even number on both sides of the sign there, you know it's a perfect square. So let's look at a question you guys can do. So why don't you guys give this one a shot now? So I'd like you to break down 54 and 64 into their prime number multiples. So you can pause it here and go ahead if you like, and hit play when you're ready to go. All right, so let's look at 54 first of all. So 54 can be broken down into 2, we'll start with 2, and 27. Well, we know 2 is as far as it can go because 2 is just 2 and 1, so there's one of our prime factors. And we know 3 can be broken down into 3 times 9. So 3 we know is 3 and 1, so that's going to be one of our prime factors. And 9 can be broken down into 3 and 3. So we've got both of our factors there. Now the question is 54 a perfect square? Well, when we list all of our factors out, it's not even because we have 1, 2, and we have 3 3's. Which means if I split down the middle, we'd have 2 times 3 is 6, and 3 times 3 is 9. So 6 times 9 does equal 54, but they're not the same number. So it is not a perfect square. Okay? So let's try the next one here. So 64. Well, we can break 64 down into 2 times 32. 2 is just 2 and 1, so that's as low as it can go, so that's a prime factor. And 32 can be broken down into 2 times 16. So we have another prime factor in that 2 there. 16 can be broken down into 2 times 8, so another prime factor. And 8 can be broken down into 2 times 4, another prime factor. And finally, 4 is 2 and 2. So now we can say 2 times 2 times 2 times 2 times 2 times 2. We have 6 2's, so if we were to split them up with 3 on each side, 2 times 2 is 4, 4 times 2 is 8, and on this side, 2 times 2 is 4, 4 times 2 is 8. So 8 times 8 should give us 64. We know that this is now a perfect square because it's the same number times itself as 64. So let's look at one more thing before we're done here today. So now the last question is, what's a square root? Well, a square root is a number multiplied by itself that equals a square number. So if we have the example of 144, we need to know what number times itself gives us 144. And there's actually 3 methods you can use to find this out for the square root. The first is just inspection, which means that you're just using your intuition that you know right away that 12 times 12 is going to give me 144. Now I should mention that this sign right here, that is the square root sign. That's not division. That is a square root number. So that's the way that just by using your intuition you could say, oh, well, square root of 144, well, that's 12, because 12 times 12 I know is 144. So that's just using, your quick method of intuition. The second method you can use to solve square roots is guess and check. Now what I mean by that is you're going to ask yourself, what times what gives me 144? Well, let's try one. 10 times 10, well, that gives me 100. Okay, so it's a little bit too low, so I'll try a number that's a little bit bigger. 13 times 13, well, that's 169, so that's a little bit too high. So I'll try something else. Oh, 12 times 12 is 144. So again, it's just kind of going back and forth and trying different ones to see until you can find the right answer. So kind of guessing and checking. And then the last way to find out is what we just did in the last pages, is prime factorization. So splitting, 144 up, I went by 4 here, and 36, and I found that I had 2 and 2 and 6 and 6. Well, I kind of didn't go all the way down, but I knew I could break it even and put 2 and 6, and 2 and 6 was 12 times 12. So any of these ways will work, okay? It's just good to know each of them and see which way works best for you. So with that, that's the end of this lesson. So what you guys can do is take a look at the assignment below and get started on that when you're ready to go.